Okay, Bismillahirrahmanirrahim and Assalamu alaikum. So we talked about the topic of this lecture in our last lecture. So we mentioned that we'll be talking about recursion in the next lecture, and this lecture is about recursion. In our last lecture, we concluded our discussion about functions. We went through the different ways of passing arguments to a function. One is called by value, the other is called by reference, and we said that we shouldn't always be using call by reference. We should only be using call by reference when it is absolutely necessary. Call by reference is when you call a function and pass the arguments in the form of references or addresses. So you give direct access to the called function or callee function. You give it direct access to the data in the caller function. Okay, so that direct access is good in the sense that it is more efficient. You don't need to make copies of the data and pass it on to the callee function. So it is more efficient. You just give it direct access to the original data. But it can be dangerous as well. Dangerous in the sense that the callee function can change that data, and at times that change can be unwarranted. Like you may not want the callee function to change that data, and sometimes you might want the callee function to change that data. So we talked about those situations as well. So if a function needs to return, say, more than one value, now that is not possible in C++ because a function can only return a single value. So if you need to write a function that needs to return more than one value, so one way of doing that is to give it multiple arguments as by reference, and let that function modify those variables. So that is how it can return multiple values to the caller function. Okay, this is one way. So we said that ideally, like if you need to pass a value by reference, you should be doing it using const reference. The benefit of const reference is like it is efficient because it is by reference, and it prevents the callee function from modifying the data in the caller function. Why? Because you are using const references. Then we also talked about namespaces and using declarations, and our discussion of namespaces would hopefully clarify the purpose of using namespaces. Okay, so we are not going to use or create our own namespaces, but this discussion was important in the context of scope of variables. So namespaces are basically named scopes, and they allow you to resolve issues with naming conflicts. So if you're using multiple libraries and those libraries happen to have functions or objects or constants with the same name, so there's a chance that the compiler will flag errors for multiple definitions of the same name. And in order to resolve such conflicts, namespaces are one way of doing that, of resolving those conflicts. In this lecture, we are going to talk about recursion. Now, recursion is something that is very important, and many people find it a little complex or difficult to understand at times. Okay, so it is sometimes it is difficult to understand, and sometimes like it makes a lot of sense, but when you think about it and when you try to write a recursive function, it may not be that easy. Okay, so first of all, like we'll talk about what recursion is recursion. You can think of it as it comes from recur or reoccur. Reoccur means something that happens again and again. So recursion is something that is happening again and again. So by recursion in the context of computer programming, what we mean is when a function calls itself, when you call a function, and that function then calls itself again and again. So this is called recursion. So right now, like we have been up until now, we have been writing functions, and usually those functions we have called those functions from the main function. Okay, so in recursion, what happens is that when we call a recursive function, we do that from the main function, and the main when the main function calls the recursive function, so after that the recursive function starts calling itself. Okay, starts calling itself. That's why it's called a recursion. The execution of the recursive function happens again and again. It reoccurs. So that is why it's called recursion. Now, why do we need to use recursion? Okay, so recursion is one way of solving problems. Recursion is you can think of it as a design pattern. Okay, we haven't talked about design patterns, but there are problems that can be solved in a particular way. There are certain classes of problems that can be solved in a particular way. So we that particular way, which allows the solution of a certain class of problems, we call it as a design pattern. We call it as a design pattern. So you can use a design pattern to solve a particular class of problems. I didn't mean to talk about it in a more formal way about design patterns, because we won't be using or talking about many design patterns, but nevertheless, like it came up. So I'm mentioning this term design pattern here. So design pattern is basically a pattern for a solution or for a design that can solve a class of problems, not just one problem, but different problems of the same type. Okay, so recursion is basically a design pattern. Using recursion, you can solve a certain class of problems. So we'll be talking about some examples. For example, I hope like you know how you have written this factorial function. I guess in one of the lab tasks I asked you to write this one. I hope you also know about the power function. You might not know about Fibonacci numbers and Fibonacci sequence. We'll talk about that. And then there is a very interesting and a very difficult problem. That problem is called the Towers of Hanoi problems. We'll talk about this problem as well. Now, all these problems, they are different problems. But all these problems can be solved using recursion. Using recursion, this one design pattern fits all these different problems. And these are not just these aren't the only problems that can be solved using recursion. There are hundreds of other problems that can be solved using recursion. In fact, there is a theorem in computer science that if you can solve a problem iteratively, if you can solve any problem iteratively, so what do we mean by iterative solution of a problem? Iteratively means if you can solve a problem using loops, so you can always solve that problem using recursion. You can always solve that problem using recursion. So this is iterative. This I'm trying to write iterative. So if you can solve a problem iteratively, you can solve that problem recursively. And similarly, vice versa. If you can solve a problem recursively, you can solve that problem iteratively as well. So this is a theorem in CS. We are not going to explore this theorem, but we are definitely going to talk about recursion in reasonable detail. So this is what recursion is. Recursion is when a function calls itself again and again. And why would a function need to call itself? We'll talk about this when we talk about factorial function and the power function. So we will talk about, or the Fibonacci function for that matter. So we will talk about like why does a function need to call itself. Okay, so and we'll write that code as well. So I hope like you have written the simple factorial function where you find the factorial iteratively using loops. So you find the factorial of a number using loops. We'll try to do that as well, so that like you can see the difference between these two implementations. So I hope like you know what recursion is. Why, how to write a recursive function in C++. So we'll talk about writing a recursive function in C++. And when you're writing any recursive function, you must remember these two cases. One is the base case and the other is the recursive case. Okay. So base case is basically the case where, or the situation, or the value of the input arguments for which you know the value of the recursive function and the function does not need to call itself. Okay, that is the base case. For example, in the case of factorial, so you know the factorial of 0 is 1. That is your base case. Okay, so or the factorial of 1 is say 1. That is your base case. So this is your base case. For the other numbers, you have the recursive case. Okay, for the other numbers you have the recursive case. Recursive case means you call the function calls itself. Sorry, the function calls itself. So if n is equal to 1, if you're trying to find n factorial, and if n is equal to 1, say for example, or if n is equal to 0, factorial of 0 is also defined as 1 and factorial of 1 is also defined as 1. So if n is equal to 0, you know the value of factorial, it is 1. And if n is anything other than 0, then n factorial is n multiplied by n minus 1 factorial. So that is, we look at it again. So when you're writing a recursive function, you need to specify at least one base case. This is extremely important. If you do not specify a base case, then you will end up writing a function that would execute or call itself indefinitely. Okay, or that will definitely lead your program to crash. The recursive case, you should write it in a way that it approaches the base case. Okay, so just like loops, when you're writing or specifying values for the loop counter, so you specify the initial value, then you specify the condition for which the loop will continue, and then you change the loop counter, and you change the loop counter in a way so that it at some point in time the condition would become false. The condition for continuity of the loop would become false. And similarly, in recursive writing, while writing a recursive function, you must specify the base case. Okay, and the base case is the case where for which you know the value of the recursive function. And then the recursive function is the recursive case is the case in which the recursive function calls itself, but it should call itself in a way such that it approaches the base case so that this function terminates execution. Okay, so let's see all these topics one by one. We'll try to look at all these examples in this lecture. We'll try to do that. If we cannot look at all these examples, then I guess uh, even a couple of examples would be enough, but I have these 4 examples and I'll try to do that. If that's not possible, maybe we carry it into the next lecture, or maybe we do it in the lab session. Okay, so let's get started. So this is basically, what is recursion? Very simply, recursion is when a function calls itself. When a function calls itself, that is recursion. Why would a function need to call itself? Okay, why would a function need to call itself? Okay, fine. When a function calls itself, we call it recursion. But why would a function need to call itself in the first function, in the first instance? So this is why. This is the classic example, and that is the example of the factorial function. This is how you define n factorial. What is n factorial? It is the product of all integers starting from n down to 1. Okay, so n multiplied by n factorial is n multiplied by n minus 1, n minus 2, n minus 3, n minus 4, and down to 3, 2, and 1. It is the product of all these integers. Okay, so this is the definition of factorial function that you implemented while finding the factorial of any integer n. Okay, this is what you did. Okay, and you did it iteratively. I hope you did it iteratively using loops. Okay, I guess that is the only way that you knew how to do it. Now you also know that there's another definition for n factorial. You can always specify, like if you have, for example, 4 factorial. Okay, say for example, sorry, okay, let me get an eraser. Uh, Erase it. Okay, let us erase this thing. Let me get the pen now. So say for example, if you have 4 factorial, so by this definition, what is 4 factorial equal to? So 4 factorial is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. This is 4 factorial. Okay, this is 4 factorial. Similarly, what is 3 factorial? So if you apply this definition, so 3 factorial is equal to 3 multiplied by 2 multiplied by 1. Similarly, what is 2 factorial? 2 factorial is equal to 2 multiplied by 1. Okay, and similarly, what is 1 factorial? So it is 1. Okay, 1 factorial is 1. We can stop there maybe. Now, if you see here, this is 4 factorial by definition. But we can also write 4 factorial is like, what is this thing? This is 3 factorial. So we can also write 4 factorial as 4 multiplied by 3 factorial. Okay? So this is kind of the recursive definition of factorial. What is a recursive definition? When you're trying to define something and you use the same thing in its definition. Here we are trying to find out the factorial of a number, and in order to find the factorial of one number, we need to find the factorial of another number. So this is kind of recursive definition. ठीक है, एक नंबर के फैक्टोरियल को डिफाइन करने के लिए हमें दूसरे नंबर के फैक्टोरियल की जरूरत पड़ रही है, इसको हम रिकर्सिव डेफिनेशन कहते हैं. ठीक है, similarly if you look at the factorial of 3, what is it? 3 multiplied by 2 multiplied by 1. Now what is this thing? Is basically 2 factorial. So we can write 3 factorial as 3 multiplied by 2 factorial. ठीक है, so in general we can write n factorial as n multiplied by n minus 1 factorial. ठीक है, so this is basically a recursive definition of the factorial function. This is kind of the iterative definition. This is the recursive definition. Recursive definition इसको हम क्यों कहते हैं? क्योंकि n का फैक्टोरियल मालूम करने के लिए हमें n minus 1 के फैक्टोरियल को मालूम करना पड़ता है. So in order to find the value of the factorial function for one number, we need to find the value of the same function for another number. ठीक है, so that is why we need to call the factorial function again. We need to call the factorial function once again. That is why we need to do that. That is why we have recursion. A function needs to call itself. ठीक है, that is why a function needs to call itself. Okay, so this is the reason why a function needs to call itself. This is the recursive definition of the factorial function. And why is this definition recursive? Because in order to find the factorial of one number, we need to find the factorial of another number, and this number fortunately is a smaller number. Okay, so this smaller number like will reach in time the base case, the simplest case. Okay, so the simplest case in this case, you can think of the base case as, say, the factorial of 1, which by definition we say is 1. So in order to find n minus 1 factorial, we need to find the factorial of n minus 2. So we can expand it. Okay, so this is the recursive definition of factorial. N factorial is equal to n into n minus 1 factorial. In order to find n minus 1 factorial, we need to find the factorial of n minus 2. Okay, we need to find the factorial of n minus 2. N minus 1 factorial is n minus 1 multiplied by n minus 2 factorial. Okay, so this is how the recursive definition works. So this is basically recursion. This is and this is the recursive. This is the factorial function. Factorial function for n. Okay, so this is the base case. If n is equal to 0 or 1, then the value of the factorial is 1. If that is not the case, if n is any other value, then the factorial of n is n multiplied by the factorial of n minus 1. So this is basically the recursive definition of factorial function. Okay, so here you can say like this is the base case, n is equal to 0. Now if you start with any positive n, if you started with any positive n, okay, so n can be any positive number, 5, 6, 10, 20, 30, whatever, okay. So in order to find its factorial, you need to find the factorial of n minus 1. So in time, this value n minus 1, it will reach 0, or the base case, okay. So this is important. You need to have a base case. You need to know the value of the function for the base case, okay, for the simplest value of the argument. And in the recursive case, you need to have a situation where this value, this argument, it reaches the base case. It reaches the base case. So n minus 1, in time it would reach the base case, okay. So this is the recursive definition of factorial function. Now, how would it, like, when you're writing a recursive function? We talked about this. So you need to have base case. What are base cases? So values of the input variable for which we perform no recursive calls are called base cases. So base cases, we can have one base case or we can have multiple base cases. So in the case of factorial function, say we have one base case, and that is the factorial of 0 is equal to 1. So for the base case, we don't need to call that function again. We know the value of the function. We know the value of the function. So there should be at least one base case. There must be at least one base case. If you don't have a base case, then that recursion would be like indefinite recursion. And another condition is every possible chain of recursive calls must eventually reach a base case. So we may have multiple recursive calls. Okay, it's not exactly necessary that we should have a single recursive call from that function. We can have multiple recursive calls, as we'll see in the case of the Fibonacci numbers, and those recursive calls must reach a base case, any base case. If you have more than one base case, so each of those recursive calls should reach a base case. So what are base cases? So base cases are those cases or those values of the input variables for which we don't need to perform recursive calls, and for which we need the value of the function, or for which we know the value of the function, or for which we know what to do, okay. So base cases are the simplest cases. So in the case of factorial function, we know the factorial of 0, it is 1, okay. So this is the base case, and then this is the recursive case, and this recursive case eventually reaches this base case, okay. What is recursive case? Recursive cases are those cases where we call the current function. So the factorial function, when it calls itself, so this is basically a recursive case. Each recursive call should be defined so that it makes progress towards a base case. So the recursive call should be in such a way that it goes towards a base case. It should not go away from the base case, okay. If it goes towards the base case, you will have a program that will execute in a finite amount of time. If it goes away from the base case, then you will have a program that will theoretically execute indefinitely, and practically it would lead to your the crash of your program. So at runtime, your program will crash at some point in time. Okay, so how to write a function? So first we'll write a function, and then I'll explain this thing here, okay. So then we'll visualize recursion. So let's go and write this code. So let us create a new project. And this is regarding recursion, okay. Okay. So first of all, let us create the normal factorial. So we'll first implement the factorial function, and we'll implement factorial function in two different ways. One is the iterative factorial function, and the other would be the recursive factorial function. So you'll clearly know the difference between the two. So we want to find out the factorial of an integer number, and that factorial would also be an integer number. So int, and we want to find it using two different ways. One is iterative factorial. So it will get an integer value as input. Okay. If you're writing the function prototype, you can simply specify it would get an integer value as input. You don't need to specify, you don't always need to specify the identifier for this integer value. Like up until now we have been writing uh, function prototypes like this. So we say it receives an input argument a, but a here is a dummy variable. Okay, so you can remove it. You can simply say, okay, this is the function, its name is iterative factorial, it receives an integer value as input argument, and it returns an integer value as output. Okay, so and similarly we would also write recursive factorial function. Okay, it would also receive an input argument. Now let us write these functions. Okay, so let us first write the iterative factorial function, and then let us write the recursive factorial function. So the iterative factorial function receives an argument by value. Okay, and the recursive factorial function would also receive an input argument by value. You can call it as n in order to be consistent with n factorial kind of thing, or you can call it a, whatever you want. You can give it any valid name. Okay, so how did you find the factorial? I hope you know this thing. So let us store the factorial value in the variable f, and let us initialize it with the value 1. Okay, so this is the iterative version of the factorial function. So f is equal to 1, say this is 1 factorial, and we want to find the factorial of n. Okay, so how did you find the factorial of n? So you can do it like this. You can say for, you can have a for loop for int I is equal to n, I greater than say 0, and minus minus I, decrement I. So basically we want to find the factorial of n. Okay, so what is n factorial? It is n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 down up until 1. So we'll start with I is equal to n, and then we are decrementing it. So n multiplied by, when we decrement it once, it would be n minus 1, decrement it twice, n minus 2, and for how long we would continue to decrement it until I becomes equal to 0, then we would stop. Okay, so while it is greater than 0, we will keep on decrementing it, and this is the variable where we would store the value of the factorial. Okay, so how are we going to store the value of the factorial? So this is how we are going to do it. F, basically it is equal to, so we are going to multiply, this is basically this thing, f is equal to, or we are assigning f the value of f multiplied by I. Okay, this is what we are doing. So I initially is n, so and f is 1. So for the first iteration or execution of this loop, f would have the value n. Okay, for the first iteration, f would have the value of n. When the loop executes for the second time, I would be decremented by 1. So then we are multiplying it with f. So then f would have the value n into n minus 1. Okay, then the third iteration, it would have the value n into n minus 1 into n minus 2. The fourth iteration, n into n minus 1 into n minus 2 into n minus 3, and this will continue until we reach 1, until we reach 3, 2 and 1. Okay, so I hope like you have written this code already, and you have some idea of how to write this how to calculate this factorial iteratively. So we are doing it iteratively using loops. So once this loop is done executing, f will have the value of the factorial, and we are ready to return it. We are ready to return it. So we'll return f. And here you can verify if it works or not. So say for example int a is equal to 5, and then we can say factorial of 5, factorial of a is, and let us call the iterative factorial function and give it the value of a. So it will find for us the value of the factorial of a. Okay, so let us compile this file and build and run it. So factorial of 5 is 125 times 4 is 20, 20 times 3 is 60, 60 times 2 is what is 60 times 2? 120, 120 times 1 is 120. Okay, so this is fine, this is correct. You can give it some other value. You can say factorial of 10. So factorial of 10 would be what? Would be this value. You can use the calculator in Windows to verify if it is correct or not. Okay, so you can verify your answers here. You can verify your answers here. Let us go to the scientific view. Okay, do we have the factorial function here? Yes, we have. So 10 factorial. 10 factorial is 362,88,00, 362,88,00. So it's fine. Our answer is fine. Okay. So this code works fine. The iterative factorial function works fine. So you can see how do we calculate the value of the factorial function iteratively using a loop. This is one way of doing it. The other way of doing it is use recursively. The other way of doing it is recursively. How do you do it recursively? So while doing it recursively, you need to specify two things. One, you need to specify the base case. Base case is the value of the factorial function for the simplest possible value of the input argument. Okay, so you can say if this is the base case, if n is equal to 0, if n is equal to 0, so we know the value of the factorial, it is 1. So we'll say return 1. If n is equal to 0, return 1. That is the value of the factorial. If n is equal to 0, sorry. If n is equal to 0, return 1. 0 factorial is 1. Else, if that is not the case, if n is non-zero, then what is factorial? Factorial is then this thing. Then you would say return n multiplied by n minus 1 factorial. Okay. If n is not equal to 0, then what is factorial equal to? N multiplied by n minus 1 factorial. So n multiplied by, how do you find the factorial of n minus 1? You will call the recursive factorial function with the argument n minus 1. Okay. So this is basically n multiplied by n minus 1 factorial. Now the recursive factorial function is calling itself. It is calling itself. This is the recursive case. This is the recursive case. This here is the recursive case. Recursive case is the case when this function, the recursive factorial function, calls itself. So it is calling itself from within its body. This is a recursive function call. This is a recursive function call. Why is it a recursive function call? Because the recursive factorial function is calling itself from within the within its own body. It is calling itself, okay, but it is calling itself with a new argument, and that argument is n minus 1. So n minus 1 means that ultimately n would reach the base case. N would reach the base case. Okay? And once it reaches the base case, then you know the value of the function. And once you know the value, once you reach the base case, then you can find out all these values of other things as well. Acha ji. So this is this is it. Like this is how you can find out uh, the factorial of a number using recursion. Okay? Now recursion is completely different. It is completely different from iterative way of doing things. This is iteration using loops, and this is recursion. Okay? So some people find it like easy to understand, and some people find it a little difficult to digest. Like how would it work? So let's see if it works or not. Okay? So let me copy this thing, and it would take more time. Okay, let us paste it here. So this is iterative factorial of a. Let us make a as 5, and this is recursive factorial of a is, and we are going to call the recursive factorial function. Okay, we are going to call the recursive factorial function. And if you want to know, like whenever the recursive factorial function is called, if you want to print some output, you can do that as well. That way, let us print out something here as well. So let's say we print this line here inside the iterative factorial function. Okay, and let me print this line on a new line, and here let us print this line here. Acha, inside the recursive factorial function. Recursive factorial function. Okay. Okay. So we'll find the factorial of a using both these functions, and you'll see that in both these cases we get the same result, but using two different methods. So iterative factorial of 5 is, so when you call the iterative factorial function first, that line is printed inside the iterative factorial function, and you execute it only once. The iterative factorial function is called only once, and you get its value 120. That's it. Now recursive factorial of 5 is, so you first call the recursive factorial function to find out the factorial of 5. So the recursive factorial function says that the factorial of 5 is 5 multiplied by the factorial of 4. So then you call it to find the factorial of 4. Then it says that the factorial of 4 is 4 multiplied by the factorial of 3. So you call it to find the factorial of 3. And that says that factorial of 3 is 3 multiplied by factorial of 2. Then you call it to find out the factorial of 2. And it says that the factorial of 2 is 2 multiplied by the factorial of 1. So you call it to find out the factorial of 1, and it says that the factorial of 1 is 1 multiplied by the factorial of 0. And then you call it to find the factorial of 0, and fortunately that is the base case. That is the base case, okay? So factorial of 0 is the base case. Its value is known. So the recursive factorial function returns you the value of 1. So now you know the value of the factorial of 0, so you can find the factorial of 1, which is 1 multiplied by factorial of 0, or 1. So 1, then you can find the factorial of 2, 3, 4, and ultimately 5. So once you reach the base case, then you can solve all the other cases, okay? And you get the value of the recursive factorial function to be 20, okay? And this is exactly what has been shown. This is exactly what has been shown in this particular slide. Okay, so say for example, here we are executing or calling the recursive factorial function for 4. So when you call the recursive factorial function for 4, so it says that the factorial of 4 is basically 4 multiplied by the factorial of 3. 4 multiplied by the factorial of 3. So you need to find the factorial of 3. Factorial of 3 is 3 multiplied by factorial of 2. So you need to find the factorial of 2. Its value is not known. So factorial of 2 is 2 multiplied by the factorial of 1. Factorial of 1 is 1 multiplied by the factorial of 0. Factorial of 0 is 1. Its value is known. So once the value of factorial of 0 is known, so you can find out the factorial of 1, which is 1 multiplied by factorial of 0. So you get the value for the factorial of 1. Once you know the factorial of 1, you can find out the value of factorial of 2, which is 2 multiplied by factorial of 1. So you get the value 2. So you have the factorial of 2. You can find the value factorial of 3, which is 3 multiplied by the factorial of 2. 3 2s are 6. And then you can find the factorial of 4. Okay. So 4 multiplied by the factorial of 3, 4, 6 are 24. That is your answer. So this is how the recursive factorial function works. It makes these recursive calls. So it basically unfolds the expression. Okay. So if you need to find n factorial, it unfolds this expression. Unfolds mean इसको फैला देता है n into n minus 1 factorial. ये फिर बन जाता है n into n minus 1 into n minus 2 factorial, n into n minus 1 into n minus 2 into n minus 3 factorial. ये आखिर में इसको स्ट्रेच करते करते 0 factorial तक ले आता है. So once you reach the base case or then you know the value of 0 factorial, फिर आप इसको वापस fold back करते हैं in order to find the value of n factorial. ठीक है? This is how recursion works in the case of a factorial function. ठीक है? This is the recursion trace. ठीक है? Recursive function कैसे फैलता है और कैसे फिर fold होता है. So this is basically a trace of that. Now we'll look at it at using another example. Recursive power function. We need to find the nth power of x. So we have base and we have exponent. So we need to find base raised to the power exponent. So x raised to power n का क्या मतलब है कि you multiply x n times. ठीक है? X multiplied by x multiplied by x multiplied by x. You do it n times. That is what it means. लेकिन इसकी एक रिकर्सिव डेफिनेशन भी है. x रेज टू द पावर n इज इक्वल टू x मल्टीप्लाइड बाय x रेज टू द पावर n माइनस 1. यानी किसी भी नंबर का इफ यू नीड टू फाइंड इट्स nth पावर, so you can find it in terms of the n minus 1th power of that number. ठीक है? So if you need to find the power of a number, if you need to raise a number, you have the base and you have the exponent. So if you need to find this thing, so you can do it this way as well. You can find the value of this power function for a smaller number of the exponent. Okay, one smaller. For example, uh, if we need to find out, say for example 5 raised to the power 4, just like the way we are doing it here. So you can find out the value of 5 raised to the power 4 recursively. Like you can say 5 multiplied by 5 cube. Okay, and similarly this is 3. You can find 5 cube as 5 multiplied by 5 square, and similarly you can find out 5 square as 5 multiplied by 5 raised to the power 1, and similarly you can find 5 raised to the power 1 as 5 multiplied by 5 raised to the power 0. And this is your base case. 5 raised to the power 0 is your base case. So you know its value. Its value is 1. ठीक है? So once you know its value, then you know the value of 5 raised to the power 1. It is 5. Okay. Once you know the value of 5 raised to the power 1, you know the value of 5 raised to the power 2. It is 5 times 5, 25. And once you know the value of 5 times 2, you know the value of 5 times 5 raised to the power 3. This value is then 5 times 25, 125. And once you know the value of 5 cube, you know the value of 5 raised to the power 4, which is 5 times 125, 625. So that is how basically the recursive power function would work. Okay? So we have, this is the base case for, we know the value of the recursive power function for exponent equal to 0, it is 1. And for the other cases where exponent is not equal to 0, it is greater than 0. So we can find out the value of that function in terms of a recursive call to the same function for a smaller value of the exponent. Okay, so let's implement this function. Let's implement a iterative version of the power function. You don't need to implement the power function, you already have a built-in function. We are implementing it just to understand recursion. Okay, so first of all, let us have an iterative power function. So int, let us have iterative power function. So we want to find out the power of base raised to the power exponent, and then let us have recursive power function. Recursive power function. So we'll have two arguments, base and exponent. Okay. So let us define these functions. I'm copying it so that I don't make any mistake in the names of these functions. And let me make things a little simpler. Okay, so this is iterative power function. So it will have two arguments, base b and say exponent e, say for example. Okay, and this is recursive power function base b and exponent e. Okay, so how do you find the power of a number b iteratively? Okay, so this is the result or answer. Int p is equal to 1. This would have the power of b raised to the power e. We want to find it iteratively. So if you need to find the power of a number, you basically need to multiply that number with itself, the exponent times. For example, if we need to find 5 raised to the power 4, okay? So 5, say, raised to the power 4, this is what it means, 5 multiplied by 5 multiplied by 5 multiplied by 5. So we need to multiply 5 4 times with itself. So this is the base and this is the exponent. So if we need to find base raised to the power exponent, we basically need to multiply b with itself, and we need to perform this multiplication e times, okay, whatever the value of e is. So we need to perform this multiplication e times. So how would we do that iteratively? Let us use a for loop, say for int I is equal to e, I say greater than 0, sorry, greater than 0, and minus I, decrement I. So we'll start, say we have exponent equal to 4. So I will start from 4. So 4, then 3, then 2, then 1, okay. And after that this loop will terminate. So we'll basically, this loop will execute basically e times, okay. the exponent number of times. And what are we doing inside this loop? So we are just multiplying p with the base. We're just multiplying p with the base. So if base is say 5 and if e is say 4, say take this case, base is 5 and e is 4. So when this function is executed, what will happen? So when you enter this function, initially e is 4, so I would be 4 and 4 is greater than 0. Okay, so you enter this loop. So first of all, you will multiply p with b, okay, and assign that value to p. So p will have the value 5 because b is 5. Then since then I would be decremented, so I would become 3. 3 is greater than 0, so you again multiply p with b. So 5 would be multiplied with 5 again. P already has 5, so it will become 25. Then 5 5s are 25. Then you decrement I, it becomes 2, and you multiply b with p, so 25 times 5 is 125. Then you multiply decrement 5, sorry I, it becomes 1. 1 is greater than 0. This condition is true. So you multiply uh, b with p, so 125 times 5, 625. And then what do? You decrement I, it becomes 0, and this condition becomes false, and you do not execute this loop anymore. So after this loop is done execution, p will have the value of the power, okay, b raised to the power e, so you return this value. This is the iterative implementation of the power function. This is the iterative implementation of the power function. Now how would you do the recursive implementation? In the recursive implementation, you first need to specify the base case. So what is the base case here? The base case here is if exponent e is equal to 0. If e is equal to 0, okay, so what is the power? Then the power is 1. You need to return 1. Anything raised to the power 0 is 1. Okay, anything raised to the power 0 is 1. This is the base case. What is the recursive case? Recursive case. Else, if e is not 0, if e is some positive value, then what is the recursive case? Then how do you need to find the power? You need to find the power like this: return b multiplied by, okay, so we basically need to specify this equation. So if n is not 0, then x raised to power n is x multiplied by x raised to power n minus 1. Okay, so x here is the base, b multiplied by recursive power. We need to call this function recursive power, sorry, again for this value of the exponent. Okay, so we are changing the exponent in a way so that it reaches the base case. We are changing the exponent in a way so that it reaches the base case. This is the recursive implementation of the power function. It is completely different from the iterative implementation of the power function. Now here this is the recursive case, and this here is the recursive function call. Recursive power function is calling itself from within its own body for a different set of arguments. Okay, base remains the same, but the exponent is decremented by 1. The exponent is decremented by 1. So this is the recursive power function. Okay. Uh, okay, so let us print that line as well. When we are inside the recursive function, so let us print this line. Okay, inside the recursive function, and let us print this line on a new line every time. Say we can get rid of this thing. Acha. Similarly, inside the iterative function, when the iterative function is called, uh, let us print this statement here as well. Inside the iterative power function, iterative power function. This is the recursive power function. Okay? Iterative power function, recursive power function. Acha ji. Now let us get rid of. Let us not get rid of this code. Let us comment this code out. Mm, Acha ji. Let us comment this code out. And let us call this function a, and say, let us say int e. So we are going to find, or say n, we are going to find a raised to the power n. Okay? So n is equal to say 4. So let us say cout a raised to the power n is equal to a raised to the power n is equal to, and then let us call the iterative power function. Iterative power function. Okay? And base is a and exponent is n. Okay? So this is, we are doing it iteratively. A raised to the power, and in brackets let us write iterative power. Okay? Achha. Similarly, let us find the power, the same thing, using recursive power function. Okay? So this is recursive power, and here we are going to call the recursive power function. Recursive power function. Okay? Achha. So we are finding the power of a. We are evaluating a raised to power n both iteratively and recursively. So we are going to get the same result, but using two different techniques. Okay? So let us compile this code and then build and run. So 5 raised to the power 4 is 625, and this is iteratively. And then when you do that, so inside the iterative power function, this statement is also printed. And then we want to find out 5 raised to the power 4 recursively. So in order to do that, we are basically calling the recursive function. ठीक है? और recursive function सिर्फ एक मरतबा कॉल नहीं होता, ये 1 2 3 4 5 मरतबा कॉल होता है. So 5 raised to the power 4 is basically 5 multiplied by 5 raised to power 3. 5 raised to power 3 is 5 multiplied by 5 raised to power 2. 5 raised to power 2 is 5 multiplied by 5 raised to power 1. 5 raised to power 1 is 5 multiplied by 5 raised to power 0. And 5 raised to power 0 is 1. So this is the base case. यानी यहाँ तक हम पहुँचते हैं. उसके बाद फिर वापस तमाम जो expressions हैं उनकी values calculate करते हैं. So in both the cases we get 625. The value, the result is the same. Iterative is faster mostly. Recursive is slightly slower. लेकिन बाज़ there are problems which at times which can be solved very easily using recursion, but they take a lot of time. uh, they may be very difficult to solve using iteration. Okay? And similarly, there would be some problems that would be easier to solve using iteration than using recursion. ठीक है? Recursion, recursively उन problems को formulate करना, that may be difficult. अच्छा जी. So this was another example of recursion. Okay, we calculated the value of power recursively. Now let us talk about another very interesting example, and this example is of Fibonacci numbers. Okay. So what are Fibonacci numbers? I guess there would be more detail about Fibonacci numbers in your book, and you can also like look up these numbers on the internet. You can find more detail about these numbers. So Fibonacci was an Italian mathematician, and it is thought that he proposed the Fibonacci numbers, but uh, and this happened around 1200, I guess. I don't exactly remember the time, but I guess it happened around 1200 something. So this mathematician was from Pisa, Italy. His original name was Leonardo of Pisa, and later he was called as Fibonacci numbers. These numbers are very interesting numbers, okay? And these numbers, this is the Fibonacci sequence. This is the sequence of Fibonacci numbers. So the first two Fibonacci numbers are 1 and 1, okay? And then the next number, you can get the next Fibonacci numbers by adding the previous two numbers. So 1 plus 1 is 2. The next number is the sum of two previous numbers. 1 plus 2 is 3. And then 5 is basically the sum of the previous two Fibonacci numbers. 2 plus 3 is 5, and 3 plus 5 8, 5 plus 8 13, 8 plus 13 21, 21 plus 13 34, 34 plus 21 55, 55 plus 34 89, 89 plus 55 144, and so on. So this is an indefinite sequence, and in this sequence the first two numbers are 1 and 1 Fibonacci. So we call, in general, we represent the Fibonacci numbers as f sub n. The first two Fibonacci numbers, like f sub 0 and f sub 1, they are equal to 1, and any other Fibonacci number for n greater than 1, you can find the nth Fibonacci number as the sum of n minus 1th Fibonacci number and n minus 2th Fibonacci number. Okay, so the previous two Fibonacci numbers, if you add them, so you can get the nth Fibonacci number. So this is what Fibonacci numbers are. This is a very simple sequence to generate, but this is a very important sequence to generate. Like this sequence of numbers, it appears in many different settings. Now some people say that the population of rabbits, it increases like this. Okay, so say the first generation of rabbits would have these two rabbits, say 1 1, and then 2 3 5 8 13 21. So this is how the population of rabbits increases in the next generations. Okay, so this is one view. You can look it up. This is something that happens almost in every field. Like these figures, they pop up in almost every field. Similarly, if you look at the branching in trees, the way the number of branches increases in trees. So you have the stem, which is say 1, and then the stem usually it divides into two branches, and then those two branches then give rise to a third one, and then 5. So if you go up, the number of branches that in trees, that the way they increase is usually using this sequence of Fibonacci numbers. Similarly, the arrangement of leaves on a stem, the way the leaves are arranged on a stem, so they also uh, uh, kind of follow the Fibonacci sequence. Now there is a very important another important characteristic of Fibonacci numbers. The ratio between two consecutive Fibonacci numbers, it approaches the golden mean, okay, or the golden ratio. So the golden ratio, you can explore it. It is also a very important ratio. Uh, um, so what is, like, you can find more about it by looking it up on the internet. So here, like, we would look at these numbers and this sequence or this function, the Fibonacci function or Fibonacci numbers or Fibonacci sequence, from a programming point of view. So I guess it is very easy to write a program which can generate uh, the Fibonacci numbers. So it's not that difficult to write a program that would generate the Fibonacci number. Okay, so you can do it iteratively. You can write a program that uses a loop to generate the Fibonacci numbers, or find out the nth Fibonacci number, or you can do it iteratively. Okay, you can find the nth Fibonacci number iteratively. So we, in this particular session, we are going to write the Fibonacci function, and that Fibonacci function would find the nth Fibonacci number. We want to find out f sub n, and we would do it using recursion. Okay, so I'll leave the iterative version of the problem for you to as an assignment. So we'll do it recursively. Okay, so how would you do it recursively? So let us define the Fibonacci function. So the Fibonacci function would find out the nth Fibonacci number. Okay, it would find out the nth Fibonacci number. So we would give it n as an argument. Let us bring it here. Let me shrink that thing. Okay, so the Fibonacci function would get n as an input argument and would return the nth Fibonacci number. Okay. So how would it do it? We are going to do it recursively. So first of all, we need to specify the base case or the base cases. Okay. Base case or base cases. Here we have two base cases. One is we know the value of Fibonacci 0. Okay. That is 1. We know the value of Fibonacci 1, f1, f sub 1 and f sub 0. These are known. F sub 0 is 1 and f sub 1 is 1. So we know these values. So these here we have like two base cases. So if n is equal to 0, what should we return? Return 1. Else if n is equal to 1, sorry, yes, n is equal to 1, what should we return? We should return 1. So here we have two base cases, and then we have the recursive case, and this recursive case is slightly different than the other ones, the previous ones. Else, what is the recursive case? So if n is not neither equal to 0 nor equal to 1, if n is some other value, then what should we return? Then we should return the sum of two previous Fibonacci numbers. So we should return Fibonacci n minus 1 plus Fibonacci n minus 2. Okay. So here, like, we are calling, this is a double recursive call. So we are calling the Fibonacci function from within the Fibonacci function, not just once but twice in a single statement. So this is kind of a non-linear call. Okay. Acha, so this is the recursive case. What is the base case? If n is equal to 0, then f sub n, the Fibonacci, the value of the Fibonacci, the 0th Fibonacci number is 1. We should return 1. Similarly, the first Fibonacci number, like starting from 0, this would be the second one. It is also 1. So f sub 0 and f sub 1, these are 1. And for any other value of n, f sub n, basically it is f sub n minus 1 plus f sub n minus 2. It is this implementation. So these are the base cases. F sub 0 is 1, f sub 1 is 1. N is equal to 0, return 1. N is equal to 1, return 1. Else, f of n is basically f of f sub n minus 1 plus f sub n minus 2. So this is what we have done here. Else return Fibonacci n minus 1, Fibonacci n minus 2. And it will find us the values of Fibonacci numbers. Okay? Let us comment out this code. Achha. And let us print the Fibonacci sequence. Okay? So let's say for int I is equal to 0, I less than say 10 plus plus I, or I less than or equal to 10 plus plus I, and then let us print these values. Okay? So let us say cout uh, cout what? Fibonacci I. Okay? Starting from 0. So we want to print its value. क्या है value इसकी? So we need to call the Fibonacci function, and we need to find out the value of Fibonacci function for I. ठीक है? So first of all, ठीक है? So Fibonacci 0, Fibonacci 1, 2, 3, 4. So basically we will print this sequence in some form. इस form में भी इसको print कर सकते हैं. Let us print it in this form and then we'll look at it. अच्छा, compile this code and then build and run. So Fibonacci 0 is 1, 1 is 1, then 2 क्या है? 1 plus 1 2, 3 is 2 plus 1 plus 2 3, 4 is 2 plus 3 5, fifth one is 3 plus 5 8, sixth one is 5 plus 8 13, seventh one is 8 plus 13 21, eighth one is 13 plus 21 34, 55, 89. ठीक है? Now we can print it in that form जो हमने वहाँ पे print किया है, in this particular form. We can say cout Fibonacci and I, ठीक है? और उसके बाद we need to print a comma and a space character, and that's it. ठीक है? And once we are done here, then we need to print out an end line character. Acha, let us increase this number. Let us say print out the first 20 Fibonacci numbers. Actually, let us build and run. So this is the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. So it matches the sequence, and after this 89 plus 144, 233, 144 plus 233, 377, 233 plus 377, 610, okay? So on and so forth. So this was about Fibonacci numbers. This was yet another problem that we solved recursively. Okay? This was yet another problem that we solved recursively. Now the last problem that we are going to talk about is this problem. It is called the Towers of Hanoi problem. Okay? Now this is a very famous problem in programming. You can look it up and you will find plenty of material about it. You will find plenty of solutions to this problem. Like people have already written code for it. Okay? Now this is a very complex problem if you think from the point of view of programming. But if you solve this problem recursively, you can solve it very easily in a few lines of code. Okay, hardly five or six lines maybe. If I ask you to solve this problem iteratively, then it would be a very difficult problem to solve. Now, what is the Towers of Hanoi problem? So the Towers of Hanoi is basically a city in Vietnam. So there was those Buddhist monks, and those Buddhist monks, like, they used to work on this problem. Now, what was this problem? This was the problem. We have these disks here, and we have these three pegs or placeholders for these disks. Okay, so these disks have circular holes inside them, and you can place these disks on either of these three, one of these three pegs. Now the problem is that you have to move this stack of disks from this peg to this blue one. Okay, so you have to move these disks from this peg to this one, and you can use this one as an auxiliary peg or something for temporary storing disks. Okay? But there are certain rules of doing it. Okay? The rules are that you can move only one disk at a time. You're allowed to move only one disk at a time. Okay? This is rule number one. You cannot, like, pick up more than one disk and move them from one peg to another. And the other rule is that each move consists of taking the upper disk from one of the stacks and placing it on top of another stack or an empty rod. So you can take only the upper disk. You cannot take out disks from in between or below. You can only take one disk, and that disk must be the uppermost disk. Okay, so for example, you can move this smallest disk here. You can move it on an empty peg, or you can move it on a peg with a stack of disks already. Okay? But there is a rule to that as well. You cannot put a bigger disk on a smaller one. Okay? No disk may be placed on top of a disk that is smaller than it. So you can only place a smaller disk on a bigger one, but you cannot place a bigger disk on a smaller one. Okay? Now, subject to these rules, it becomes a little difficult. Like, it's not that simple then to move these disks from one peg to another. But there is a very simple and general rule to it. If you need to move these disks uh, to this peg, okay, so what you need to do is you first need to move these disks, these number of disks, these disks, you first need to move them here, and then you need to you first need to move these disks here. Okay? So for example, if we have 4 disks here, so we have total of 4 disks here. So the first thing that you need to do is you need to move what do you need to do? You need to move 3 disks here. Okay? The bottom 3 disks. You need to move the bottom 3 disks here, and then the top one should be moved here. And once you do that, so then you can move this disk that you have moved here to the destination. Okay, so the first thing that you need to do is, if you have to move these disks, 4 disks, from the source to the destination, so in order to be able to do that, you need to move 3 disks to the destination and 1 disk to this auxiliary place, and after you have done that, you need to move this 1 disk to the destination. Okay, so these are kind of 3 moves. If you have to move n disks from the source to the destination, so first of all you need to move n minus 1 disks, okay, from the source to the destination. Then you need to move the smallest, this 1 disk, from the source to the auxiliary place, and after that you need to move sorry you need to move n minus 1 disk from source to destination. Then you need to move the last one. Let me Okay, so let us look at this figure. This is what we need to do. We need to move these disks from here to this place, and we are going to do it in 3 steps. Okay? We are going to do it in 3 steps. What are those steps going to be? So first of all, we need to move the topmost uh, disks, n minus 1 disks. We need to move those disks here to the auxiliary peg. Okay? Then we need to move the biggest or largest disk to the destination, and then we need to move the topmost n minus 1 disks to the destination. Okay, so it is going to be in 3 steps. So if you have n disks on the source and you need to move those n disks here, so it has to be done in 3 steps. First, you need to move n minus 1 disks to the auxiliary. You need to move these disks here to the auxiliary location, the top n minus 1 disks. Once you have done that, then you can move the largest disk from the source to the destination directly. So then you can move the largest disk from the source to destination. And once the largest disk has moved to the destination, you can move the n minus 1 disk on the auxiliary peg to the destination. Okay? So these are the 3 steps that you have to do. And you have to do these 3 steps recursively. What do we mean by recursively? By recursively, we mean that you can only, like, movement of disks is simple if you have to move only one disk. If you have to move only one disk, if n is equal to 1, then you can do it simply or directly. If you have to move more than one disks, then it is not that simple. Then it has to be done recursively. For example, like here, we first need to move n minus 1 disks to this place. Okay? Now, if you have to move n minus 1 disks uh, from this place to this place, you have to do this in 3 steps. What is it? So first of all, we need to move n minus 2 disks from here to here. Then we would move the largest disk in this stack, which is the red disk, because we have to move n minus 1 disk. So in these n minus 1 disk, red one is the largest. So then we can move the largest disk from here to the destination. And once this has been done, so then we can move these disks to this place. Okay? Now this has to be done recursively. Whenever you have more than one disks, you have to do that process recursively. For example, if we need to move 2 disks here, so this has to be done recursively. If you have to move 2 disks here, so before doing that, you need to move 1 disk here. Okay? And then the largest disk should be moved here, and then that the other disk should be moved here. So the first step that you need to do is move 1 disk here, and then take the blue disk here, and then move this disk here. So these 3 moves would basically mean that these two disks, these two, have been moved to this place. Okay? Acha. Then once, like, this movement of 2 disks from here to here, this is done in these 3 steps. Then we can move the red disk. This is a single disk, so we can move it easily. Then we have to move these 2 disks back here. Now movement of these 2 disks would also take these 3 steps. Okay. So if we have to move these 2 disks here, for that we need to move 1 disk here. Okay. So the first disk would be कि इस red वाली को हमने यहाँ पे रखना है. फिर इसको हम यहाँ पे डेस्टिनेशन पे रख लेंगे और फिर इस रेड वाली को वापस रख लेंगे, ठीक है। तो ये जो 3 स्टेप्स हैं दे विल इंश्योर कि ये जो 2 डिस्क्स हैं ये यहाँ पे मूव कर जाएं, ठीक है, ये यहाँ पे मूव कर जाएं। वंस दिस इज़ डन तो देन यू कैन follow with the other steps, ठीक है। So the Towers of Hanoi problem is complicated, but you can solve it very easily using recursion. It is very recursive in nature. The base case for the Towers of Hanoi problem is when you have a single disk. If you have a single disk, you can move that disk from the source to the destination, from the source to the destination, ठीक है। But if you have more than one disks, so you cannot move those disks directly. Then you have to follow a recursive procedure, ठीक है। अच्छा, and that recursive procedure is basically this procedure. So मैंने आपको like I explained the Towers of Hanoi problem only briefly. You can look it up. You can learn about it in more detail, and you can then we can write a program for it. A program. What does the program for Towers of Hanoi problem does? So basically, it would help solve this puzzle. अगर आपने टावर्स ऑफ हनोई के प्रॉब्लम के लिए प्रोग्राम लिखना है तो दैट प्रोग्राम वुड मीन कि यू हैव टू राइट कोड विच वुड प्रिंट आउट द स्टेप्स, कैसे डिस्क को मूव करना है, कहाँ से कहाँ डिस्क को मूव करना है। सो बेसिकली वो जो मूव्स हैं वो आपने प्रिंट करने हैं। सो से फॉर एग्जांपल ये जो पेग है, दिस इज़ पेग नंबर पेग ए, दिस इज़ पेग बी एंड दिस इज़ पेग सी। इनको हमने ए बी और सी के नाम दे दिए, ठीक है। So जो Towers of Hanoi का problem है, it would print out the steps के move one disk from A to B, या move one disk from B to C or C to A. So it would basically print out these steps. So that, and following those steps we would be able to solve the problem, ठीक है। So let us write the code. I'll write the code. Maybe it would make sense to you, you would understand it, or maybe not. If you don't, so I would like you to spend some time on this problem and learn more about it. Look at you can find a lot of online resources about this problem. You can even do it by yourself. Yeah, like you can follow these steps, ठीक है। So the rule is the general rule for solving Towers of Hanoi problem is कि अगर आपने n disks को move करना है, so these are the steps. Let me write down the steps for you. The algorithm for Towers of Hanoi is, now the problem is that we have to move n disks from source to destination. How would you move these n disks? So you have to do it in 3 steps. First of all, move n minus 1 disks from source to auxiliary, ठीक है। Auxiliary is the temporary disk. So source, sorry, temporary peg. So आपके पास 3 pegs हैं. One is source, one is destination, and the third one is auxiliary. You can use it for temporary storage. So the first thing that you need to do is move n minus 1 disk from source to auxiliary. Next, move one disk, ठीक है, which is the largest disk from source to destination. Achha, once you have moved the largest disk, then you can move the n minus 1 disks that you placed on auxiliary. Move n minus 1 disks from auxiliary to destination. From auxiliary to destination. So these are the 3 steps. And all these 3 steps, they are recursive in nature. Okay, they are recursive in nature. So these are basically 3 recursive calls. Okay. Acha. So I'll write this code for you. and I hope like you would be able to make some sense out of it. So let us write the Towers of Hanoi code, the code for Towers of Hanoi. Okay. Let me comment out this code. Okay, so this code has been commented out. Now we will write the Towers of Hanoi subroutine. So that subroutine would be our function would return nothing, void. We don't need to return anything. We just want to print out the steps कि किस कहाँ से डिस्क को मूव करना है कहाँ तक, ठीक है, कहाँ पर मूव करना है. So let us call this function as Hanoi. So void Hanoi. Now Hanoi would get these arguments. First it would get the number of disks, then it would get the source peg, A है, B है, C है, the auxiliary peg and the destination peg. ठीक है. So you have to specify कितनी disks move करनी है, source कौन सी है, auxiliary कौन सी है, destination कौन सी है. ठीक है. So we have to specify these things. And these are characters. हमने उनको नाम दिए हैं A, B और C. ठीक है. So we have called them as peg A, peg B, peg C. So अच्छा जी. So let us write this function. Technically it is a subroutine, so because it does not return any value. अच्छा. So first of all, int n, this is the number of disks. Character source, this is the source peg जहाँ से disk, जहाँ पे disks पड़ी हुई हैं, जहाँ से उठानी हमने move करनी है. Character auxiliary, this is the auxiliary peg, name of the auxiliary peg. ठीक है. Temporary storage के लिए जिसको हम use कर सकते हैं. And character destination. ठीक है. So this is the destination peg जहाँ पे हमने disks को ultimately move करना है. अच्छा, what would be the base case in the case of Towers of Hanoi? The base case is when you have to move only one disk. If n is equal to 1. If n is equal to 1. This is the base case. This is the simplest case. If n is equal to 1, so what should you do? You simply need to move, you simply need to say move one disk from कहाँ से कहाँ पे? From source to destination. डायरेक्ट सोर्स से डेस्टिनेशन पे आपने एक डिस्क को मूव कर देना. So this is the simplest case. This is the base case. ठीक है. So what is the base case? Base case is move one disk from source to destination. अच्छा, source और destination यहाँ पे specified होंगे. ठीक है. So these would be names of the peg, and these are single characters. You can use some other way of naming these pegs. Else, what is the recursive case? So here we would have three recursive cases. ठीक है. Three recursive calls. Else, if n is not equal to 1, then what do we need to do? We first need to move, the first thing that we need to do is we need to move, हमारा algorithm क्या कहता है? n minus 1 disks from source to auxiliary. हमने n minus 1 disks को move करना है source से auxiliary पे. How are we going to move it? We are going to call the function Hanoi. इसको हमने n minus 1 disks पकड़ाने. अच्छा, अब हमारा source जो है वो तो source है, ठीक है, और destination क्या है? हमने source से move करना है auxiliary पे. So हमारा जो destination है वो ऑक्सिलरी है और हमारा जो ऑक्सिलरी है वो हमारा डेस्टिनेशन है। ठीक है, व्हाट डज दिस मीन, यानी हमने n-1 डिस्क को मूव करना है फ्रॉम सोर्स टू ऑक्स। ठीक है, सोर्स से ऑक्सिलरी पे मूव करना है। तो इस मूवमेंट के लिए n-1 डिस्क की मूवमेंट के लिए आवर सोर्स इज द सोर्स पैग बट आवर डेस्टिनेशन इज द ऑक्सिलरी पैग, और जो ओरिजिनल हमारा डेस्टिनेशन है उसको हम एज टेम्परेरी पैग यूज करेंगे, जहाँ पे हम टेम्परेरीली डिस्क को स्टोर कर सकते हैं। ठीक है, अच्छा, नेक्स्ट वी हैव टू मूव द लार्जेस्ट डिस्क। ठीक है, लार्जेस्ट डिस्क उसको मूव करना है। सो लार्जेस्ट डिस्क को हमने कहाँ से कहाँ मूव करना है, हमने डायरेक्ट सोर्स से डेस्टिनेशन पे मूव करना है यूजिंग ऑक्सिलरी एज ऑक्सिलरी। ठीक है, सो इसको हमने डायरेक्ट सोर्स से डेस्टिनेशन पे मूव करना है। एंड द थर्ड वन इज you can either call Hanoi function with n is equal to 1 argument, or you can simply write this step कि see out move one disk from source to destination। ये दोनों काम कर सकते हैं, but let us make it this way। इसके बाद तीसरा स्टेप क्या है, हमने ये जो n-1 डिस्क्स जो हमने ऑक्सिलरी पे रखे थे इनको हमने अब डेस्टिनेशन पे मूव करना है। ठीक है, so we have to move those n-1 disks which we placed on the auxiliary peg। so अब वो कहाँ पे पड़े हुए हैं, auxiliary peg पे। तो इस मूव के लिए source is the auxiliary peg, डेस्टिनेशन तो डेस्टिनेशन ही है, लेकिन auxiliary peg जो है ना वो हमारा source peg, ओरिजिनल source peg हो जाएगा, और डेस्टिनेशन इज डेस्टिनेशन। ठीक है, तो वो डेस्टिनेशन पैग ही है। अच्छा जी, so this is how the else block would work। This is how the else block would work and this is the base case। यहाँ मैंने ये ब्लॉक क्यों क्रिएट किया है, बिकॉज when n is not equal to 1 so I want all these statements to get executed। ठीक है, so else के बाद अगर if there is a single statement you don't need to create a block, but if there are multiple statements then you need to have a block। so the execution of this whole block is basically connected with this condition now। अगर ये condition false है तो ये पूरा block execute होगा। ठीक है, now this is the entire solution to the Tower of Hanoi puzzle, and it is hardly like how many statements, 1 2 3 4 4 or 5 if you include this condition as well। so these are basically 6 statements। ठीक है ना, if else और ये तमाम को अगर आप शामिल कर लें, so these are basically 5 or 6 statements, and these 5 or 6 statements, these are very simple and very elegant and they solve this very complicated problem as you would see। ठीक है, so let us test this problem। let us say we have characters s, ये हमारा source है, so इसको हम नाम दे देते हैं a, then character हमारा auxiliary, इसको हम नाम दे देते हैं, या इसको आप कहें जी src auxiliary। अच्छा, दिस इज b, और फिर हमारे पास डेस्टिनेशन इज इक्वल टू से c, ये उनके नाम है। ठीक है, तो सोर्स पैग इज a जहाँ पे ओरिजिनली डिस्क्स पड़ी हुई हैं, जहाँ पे हमने मूव करनी है दैट इज पैग c, और पैग b इज बेसिकली ऑक्सिलरी। ठीक है, और नंबर ऑफ डिस्क्स जो हैं स्टार्ट कर देते हैं विद 3। सो वी हैव टू मूव 3 डिस्क्स। ठीक है, वी हैव टू मूव 3 डिस्क्स। तो कैसे करेंगे, सो वी नीड टू हैव दो स्टेप्स, या 2 डिस्क्स के लिए भी यू कैन ट्राई। लेट अस ट्राई फॉर 2 डिस्क्स, दैट वुड बी सिंपल। ठीक है, इनको फॉलो करना, these would be just 3 steps, 3 steps में हम इनको मूव कर सकते हैं। so if you have to move n disks the number of moves that you would require is 2 raised to the power n minus 1. So n is 2, so 2 raised to the power 2 is 4, 4 minus 1 is 3. So 3 steps में आप इसको कर लेंगे. So let us print cout moving n disks from peg कौन सा source to peg destination. ठीक है. अच्छा, and then say we print the steps. So let us print these dashes. इसके बाद फिर वो steps आ जाएंगे. ठीक है. And how would those steps come? So we are going to call the function Hanoi, और उसको हम ये arguments देंगे n, then source, aux, destination. ठीक है. अच्छा. So let us build and run. See what happens. अच्छा. So these are the 3 steps. Move one disk from A to B, move one disk from A to C, and then move one disk from B to C. And the steps seem to be like good enough. ठीक है. अच्छा, हम थोड़ा सा क्या करते हैं? Let us follow these steps. So this is say disk number 1. Let's go back. This is say disk number 2. Okay. अच्छा, इसको थोड़ा सा कलर चेंज कर देते हैं. अच्छा, this is peg A. Say here we have A. इसमें थोड़ा सा टाइम लगेगा. अच्छा, here we have, this is peg A. ये A पे पड़े हुए हैं. ठीक है. peg A, control plus C, and control plus V. अच्छा जी. This is peg B. दोबारा से control plus V. This is peg C से. ठीक है. So this is peg B. This is peg C. अच्छा, what did we ask our program? Okay, we have to move these 2 disks from A to C. ठीक है. So moving 2 disks from A to C. What are the steps? Move one disk from A to B, one from A to C, then B to C. So one from A to B, one from A to C, then one from B to C. ठीक है. ये steps अगर आप follow करेंगे तो वो move कर जाएंगे without breaking those rules. And we have done it. ठीक है, without breaking the rules. Now let us increase the number of disks. One more. मैं आपको 3 के लिए demonstrate कर देता हूँ. And उसके बाद फिर we leave it at that. ठीक है, आप औरों के लिए इसको verify कर सकते हैं. So let us add another disk. इसको चलें black कर दें. So let us run this program for 3 disks now. So we want to move 3 disks from A to C. So 3 disk का मतलब ये है कि 2 raised to power 3 8 minus 1 7 steps होंगे. ठीक है. So let us build and run. So we have 1 2 3 4 5 6 7 steps हैं. ठीक है. If you follow these steps you will be able to move all the disks. मैं आपको सिंपल वो recursive case समझाता हूँ. अच्छा, हमने 3 डिस्क्स को मूव करना है फ्रॉम A to C. इसका मतलब ये है कि हमने पहले इन 2 डिस्क को मूव करना है फ्रॉम A to B, फिर सबसे बड़ी वाली डिस्क को मूव करना है फ्रॉम A to C, और फिर इन दो डिस्क को जो जिनको हमने बी पे रखा था उनको मूव करना है फ्रॉम बी टू सी। अच्छा, जो पहला स्टेप है वो ये है इन दो डिस्क को मूव करना फ्रॉम ए टू बी। अब इन दो डिस्क को अगर हमने ए टू बी को मूव करना है तो उसके लिए ज़रूरी है कि पहले इस डिस्क को हम मूव करें फ्रॉम ए टू सी, फिर सबसे बड़ी वाली डिस्क को मूव करें फ्रॉम ए टू बी, और फिर सी पे जो हमने डिस्क रखी थी उसको यहाँ पे मूव करें। तो द फर्स्ट मूव वुड बी फ्रॉम ए टू सी, ठीक है। एंड दिस इज व्हाट आवर प्रोग्राम आल्सो टेल्स, मूव वन डिस्क फ्रॉम ए टू सी। फिर हमने बड़ी वाली डिस्क को फ्रॉम ए टू बी मूव करना है, मूव वन डिस्क फ्रॉम ए टू बी। फिर हमने यहाँ पे सी पे जो डिस्क रखी थी तो उसको हमने यहाँ पे लेना है। तो ये वो जो पहला स्टेप था ना कि यहाँ से दो डिस्क को रखना है बी पे, ये वो कंप्लीट हो गया। अब हमने बड़ी वाली डिस्क को मूव कर देना है फ्रॉम ए टू सी, ठीक है। मूव वन डिस्क फ्रॉम ए टू सी, ये वो बड़ी वाली डिस्क की मूवमेंट हो गई। अब हमने इन दो डिस्क को इसके ऊपर रखना है। तो दो डिस्क को मूव करना है फ्रॉम वन पेग, तो हमने तीन स्टेप्स चाहिए होंगे। इन दो डिस्क को हम कैसे यहाँ पे रखेंगे, उसके लिए पहले इस डिस्क को हमने यहाँ पे मूव करना है, ठीक है। फिर बड़ी वाली डिस्क को हम यहाँ पे रखेंगे और फिर इस वाली डिस्क को हम इसके ऊपर रख लेंगे, ठीक है। सो दिस इज हाउ बेसिकली यू मूव n disks from A to C, ठीक है। So the first thing that you need to do, you need to move n minus 1 disks uh, to the auxiliary peg, and then move the largest disk to the destination, and then the auxiliary peg पे जो आपने n minus 1 disks रखी हैं, so you can move those disks to the on the destination, ठीक है। लेकिन this process is recursive. You can only move things when you have to move only one disk. तब आपको पता होता है कि मैंने क्या करना है। जब आपको एक डिस्क से ज़्यादा मूव करनी हो, so then you have to follow that recursive these steps, और आप इनको तब तक फॉलो करते रहेंगे जब तक आपको एक डिस्क को मूव करने का वो ना मिले, ठीक है। अच्छा, let us try more disks. इनको ज़्यादा डिस्क को मूव करते हैं, से 10 डिस्क अगर हों, 10 डिस्क अगर हों तो 10 डिस्क अगर हो ना तो 2 raised to power 10 is 1024, minus 1 is 1023. So we'll need 100 and 1023 moves in order to move 10 disks, ठीक है। So if we run this program, so it will take some time, and then you will have 1023 आपके पास moves होंगी, और उन moves को follow करके you would be able to moving 2 disks। ये क्यों 2 आ रहा है moving, अच्छा ये n है, this is n, and n is equal to 10, ठीक है। So this is the sequence of steps that we need to follow in order to move n disks or 10 disks, ठीक है। ये 1023 steps हैं जिनको हमने follow करना है, ठीक है। So I hope like you I'm not sure whether you have completely understood the Towers of Hanoi problem puzzle. I hope you have some idea of the Towers of Hanoi problem. It is an interesting problem, and it can be solved very easily through recursion. So I hope like you can appreciate this solution as well, ठीक है। इसको भी आप follow कर सकते हैं। I hope like you would be able to follow these this the way this algorithm works. But these different ये जो हमने problems solve किए हैं, they basically are examples of the power of this technique recursion, through which you can solve very simple as well as very complicated problems very easily, ठीक है। So Towers of Hanoi is a very complicated problem or puzzle to solve iteratively. Now consider कि अगर आपको कहा जाए कि you have to solve this problem using loops, ठीक है। So then maybe you'll find it a little difficult to think of a solution that solves this problem iteratively, ठीक है। But nevertheless like it can be solved iteratively, ठीक है। इसको आप iteratively solve कर सकते हैं। That is what the theorem says. If any problem can be solved recursively, it can also be solved iteratively. And similarly, if there's a problem which can be solved iteratively, it can be solved recursively. Okay? So it can be solved iteratively, but it would be a difficult solution to come up with. So this is all about recursion. It is very important, and you need to understand it. Okay, and that's it for today. That's it for today. Okay, see you later.